Wolfram Mathematica is included with the default Raspbian operating system. It's a powerful language used for math computation and engineering. For example, you can plot the formula of a sine wave and see the result in a notebook. Let's take a look at how to use Mathematica to control the Raspberry Pi GPIO.
Hi, I'm Mark Neiman Ross, and welcome to this week's edition of Raspberry Pi Weekly. Every week, we explore the Raspberry Pi and share useful tips.
Before we start with Mathematica, turn off your Raspberry Pi and build the simple circuit I've shown in the exercise handout included with this episode. Very simply, connect a switch between GPIO 4 and ground and an LED between GPIO 26 and ground. And I'm going to give you a couple of points here. So this is a switch. Connect a switch between GPIO 4 and ground, and then connect an LED. There's connect an LED. When you've completed the circuit, turn the power back on. You'll find two versions of Mathematica installed on your Raspberry Pi. Look under the main menu, Programming. You'll see Wolfram with a wolf's head. This provides a command line interface to the Wolfram language. You'll also see Mathematica with a starburst icon. This provides a graphic user interface and a notebook environment. I've created a notebook for this session. You'll find it in the exercise files. Double-click on the notebook and you'll open Mathematica. You'll see a red starburst, a splash screen you can close, and then the contents of this notebook. Place the cursor in the line of code for Device Configure. Then, mouse to Evaluation, Evaluate Cells. The first command takes a minute to warm up. Expect a brief wait. You'll see Running in the title bar, and then you'll see a return value. In this case, out bracket 1 equals 4 assigned to input and 26 assigned to output. This configures GPIO 04 to be an input and GPIO 26 to be an output. Now the documentation says this step isn't necessary, but I've included it to make sure the GPIO pins are set up correctly. Now you're ready to turn on the LED connected to GPIO 26. Select the line with device right GPIO and then 26 assigned to 1, then Evaluation, Evaluate Cells. You'll see the LED turn on. The device right command selects the GPIO device and assigns a value of 1 to GPIO 26. Note this isn't board pin 26. It's the BCM or GPIO pin 26. To turn the GPIO LED off, select device right, GPIO 26 assigned to 0, and then Evaluation, Evaluate Cells. And you'll see that the LED turns off. Assigning a 0 to the pin turns the signal to low. There are only two values for device right, 0 and 1. Reading a switch is similar, but with a few modifications. Select the line that says GPIO 4, and then Evaluation, Evaluate Cells. The return value will indicate that 1 is assigned to 4, which indicates that GPIO 4 is equal to 1. In Mathematica terminology, this is an assignment, also a key-value relationship. What's important is that you'll need to retrieve the value from this data structure to find out the state of the switch. Note that the first line of the out value is a description of the assignment. Don't be fooled, this isn't a number. The greater than and pipe symbols indicate that this is an assignment. In the next line, then, is the value 1. This is printed because the print statement specifies the value for the key, described as 4. Again, it's a key-value relationship. So I stored the return value in my var, and then printed the key 4 of the variable myvar. That's where the 1 came from. Let's look at this in action. Examine the do loop at the bottom of the notebook. The do in the first line couples with the last line, stating do this operation for infinity times. It's an infinite loop. Each time this loop runs, it uses an if statement to read the value of GPIO 4. If that value is greater than 1, which is the value if the switch is up, then the if statement will select the first option, device write 26 assigned to 1, which assigns 1 to GPIO 26, which turns on the LED. If you move the switch, GPIO becomes 0, and since 0 is not greater than 0, it evaluates as false, and the LED turns off. To terminate this loop, go to Evaluation, Abort Evaluation. The loop will stop running, and be sure to reset the LED by writing 0 to GPIO 26. I've noticed that Mathematica is a bit touchy about the state of the GPIO. If you find the commands non-responsive, you might want to save your work and reboot the Raspberry Pi.
Thanks for joining me for this episode of Raspberry Pi Weekly. Be sure to join the LinkedIn group and check out previous episodes on LinkedIn Learning. I'll see you next week with more Raspberry Pi adventures.